welcome everyone who's on the line to our Alaska Collaborative on Health and the Environment teleconference. This month's call is titled Holding Corporations Accountable, the Role of Litigation, Regulation, and Research to Address the PFAS Problem. And joining us, we have the Executive Director of the Green Science Policy Institute, Arlene Blum, and attorney and author, Rob Bilott. I have a few other announcements to make, but I just wanted to take a second and welcome you to our call, and thank you so much for joining us today.
We're delighted to be here. Thank you for putting it on.
Yeah. So we're pleased to let everyone know that Rob Bilott will be traveling to Alaska's capital of Juneau to speak with our state legislators at briefings and a hearing on March 9th. So we're organizing a public screening of the film Dark Waters and an in-person conversation with Rob on the evening of Monday, March 9th at 7 p.m. at the Centennial Hall in Juneau. And so if this interests you, stay tuned to our website or call our office here in Anchorage at 907-222-7714. So my name's Nick Reardon, and on behalf of Alaska Community Action on Toxics, I'll be facilitating today's call. And for those of you not familiar, CHE Alaska, it's a regional partnership group of the National Collaborative on Health and the Environment, and we aim to advance knowledge and effective action to address these growing concerns about the links between human health and environmental factors. And you can find more information at our website, akaction.org, or healthandenvironment.org. But let's get on to the business here. I sent a link to Dr. Blum's presentation slides yesterday to registered listeners, but you can also find those at our website at akaction.org and by clicking on the title of today's call. And Rob Bilott won't use any slides, so don't go searching for those. As usual, it's an audio-only teleconference, not a webinar, so you'll need to click through the slides yourself to follow along. And the call will be 1 hour, and we'll have about 10 minutes at the end where we can invite questions and comments. So without further ado, we're honored to have on our call today, and we'll begin with the founder and executive director of the Green Science Policy Council, author and research associate in chemistry at UC Berkeley, Dr. Arlene Blum. Welcome, Dr. Blum. You may go ahead and begin.
Well, thank you so much for inviting me and for all your great work in Alaska. My talk's on reducing the use of PFAS for healthier products, people, and planet. And in the second slide, to introduce you to our institute, we're scientists who do research, but research with a goal of changing policy and purchasing. So we write papers and educate decision makers in government and in business, educate and have retreats. And at our very first retreat, we asked the question, what do we do about the tens of thousands of chemicals that are in everyday products, and that there are a lot of them that we know are harmful, and we need to find a way to reduce exposure. And there are a number of problems, as in slide 3, the regrettable substitution problem. On the left, you have a flame retardant called ether. If you have an older TV, about 15 to 20% of the weight of the plastic in your TV is indeed ether. And it comes out into dust and can cause harm. After years of research, it was found to be highly persistent, bioaccumulative, toxic. Then there were years of advocacy. Finally, ether was phased out, and the replacement on the right is decaethane, and very similar in structure, function, and harm. It's expensive to change chemicals in manufacturing processes, and the chemical producers often come up with something almost identical where we don't really have enough information, and that's the regrettable substitution problem. Another problem in slide 4 is that there are tens of thousands of chemicals, and as I said, it takes years of advocacy and research to phase out one, and there's a bewildering array. But one solution in slide 5 is to group the chemicals into similar classes with similar structure or function, and then we can think about whole classes of chemicals all at once and deal with these overwhelming numbers. In slide 6, you can remember to, if you want to learn more, we came up with 6 classes that contain most of the chemicals of concern in everyday products. And we have 4-minute videos on each of the 6 classes with an introduction. So in 7 times 4, 28 minutes, you can learn the basics about these classes, where they're used, why they're harmful, what you can do to reduce exposure and harm. And we always put an optimistic story in each class because we are optimistic that once we understand chemicals and we think about them in families, we can make big progress. Today, we're going to be talking about the first class, highly fluorinated chemicals. Now, all these classes and highly fluorinated chemicals, which are now being called PFAS, that have valuable uses. So we don't say you should never use them under any circumstances. We say you should ask, if a chemical is in a class of concern, is it necessary? If you say to a mom, you can have a really nice white shag stain repellent carpet that withstands chocolate milkshakes and wine, but the chemicals that are making the carpet stain repellent are going to be in your children's bodies for years, causing harm, and on the planet forever, they may think it's not worth it. They might get a brown carpet that doesn't need these chemicals. And if they really want that white shag carpet, they might say, is there a safer alternative? And that's where green chemistry comes in, making safer alternatives to these potentially harmful chemicals. So let's talk now about PFAS, per and polyfluoroalkyl substances. We're on slide 8. And there's a bit of alphabet soup here, so I'm going to try to explain it. PFAS, and we call them highly fluorinated also. It's a carbon chain all surrounded by fluorines, and it's a class of more than 4,000 different substances. The 2 shown here with very similar sorts of names are PFOA, P-F-O-A, which refers to the acid at the end after 8 carbons, carboxylic acid, or PFAS, P-F-O-S, which has a sulfonic acid at the end. And those are the 2 that were used a lot for decades, and those are the 2 where there's the most science. So why are these chemicals so useful and so problematic? And the answer is the carbon-fluorine bond. That's the strongest bond in the periodic table. It takes perhaps the energy of lightning to break that bond. And so this gives these molecules lots of useful properties, oil and water repellency, but it also means that they are forever chemicals. They never break down. And the ones that have been studied have been found to have toxic properties. So the first big interest in these came up in the Ohio River Valley, where PFOA was used to manufacture Teflon, released into air and water. More than 70,000 residents had contaminated drinking water. Rob Bilott, who you're going to hear from, is going to tell you this amazing story of how, with the first settlement, they did a study of 40,000 residents, a C8 health study, and began to really learn about the harm of these chemicals. Slide 10, Dark Waters is an amazing story movie, and I really recommend it. So all of us in slide 11 pretty much have PFAS in our bodies, and thanks to Rob's health studies that were financed by his litigation, we have found a variety of health risks from these chemicals. So C8, where you have 8 carbons surrounded by fluorine, and 2 examples are PFOA and PFAS that we've been talking about, have been phased out due to their extreme persistence, bioaccumulation, and toxicity. And these things have actually been known amazingly since the 60s. It took about 50 years, from about 65 to 2015, for them to be phased out. In spite of serious knowledge of harm, and I think one reason is because they are not considered hazardous substances. But when C8 was phased out, the substitute was C6, which is quite similar in persistence, bioaccumulation in plants. It's suspected to be toxic, and as we learn more about some of these alternatives, they're being found to be toxic. The smaller molecules move faster. There are lots of them. It's harder to measure and monitor them, and filtration that removes C8 in many cases does not remove C6. So they're what's called a regrettable substitute. However, the chemical industry who made it do a lot of advertising in slide 13 that C6 is really fine, and as long as you don't have PFOA, it's fine. So there's all this advertising of PFOA-free products, and I think a lot of manufacturers take some comfort in statements like they're safe for their intended use. And one that makes always gets a laugh from chemists is C6 polymers cannot break down to C8. So if you have 6 molecules, it's 6 carbons, it's not going to break down to C8, but that does not mean it's safe. And but I think a lot of products now contain C6, and the people who make their products do believe these ads. I first started working on this in 2013, learned of the harm and organized a group of scientists to have a monthly call on the science and policy of PFAS. We've been having a call a month since 2013. In 2015, we issued a statement, the Madrid Statement on highly fluorinated chemicals, calling on the international community to limit the use of the whole class to essential uses. And building on that, we had a large PR campaign. There was a lot of press, and people started really learning about PFAS and also about Rob Bilott's work. The next year, we worked on a paper tracking places where drinking water is contaminated to the sources, found industrial sites, airports, military and regular and wastewater treatment plants were some of the sources. Just as our paper was coming out, the EPA set a health time advisory level of 70 nanograms per liter for PFOA and some of PFOA and PFAS, and we calculated that 6 million people's drinking water was contaminated. The levels have been going down. In slide 16, you can see New Jersey set a level, it's an enforceable level of 14. New York is setting levels of 10. There's some extraordinarily low levels being suggested. As the level goes down, the number of people with contaminated drinking water goes up. Quick examples of PFAS problems. In Michigan, Wolverine treated leather with Scotchgard, dumped the leather into sludge was applied to fields. People in Grand Rapids area have PFAS levels up to 800 times higher than the EPA health advisory level. New Mexico, Air Force Base led to contamination of a farmer's cows. Again, PFAS levels up to 170 times the EPA health advisory level. In Maine, paper mill sludge led to contamination and again, harm for a dairy farmer. Maine has taken action that biosolids must be tested for PFAS. The cost of clean drinking water is extraordinary. In the Cape Fear area, there was contamination from another DuPont plant making Teflon. They estimate it would be $46 million to build a water filtration plant to do carbon filtration, $2.7 million to operate it each year. But that plant is unfortunately additionally has a lot of other molecules, smaller molecules that aren't removed by carbon filtration. So an estimate of reverse osmosis, which takes out all the harm, was $99 million to build and $2.9 million to operate. So incredibly expensive. And Detlef Knopp, a scientist in North Carolina who first brought this contamination to the general public, told us something that I always remember. He said when it rained in North Carolina and the rain went through the trees, the level of PFAS went up. That's from air contamination from the plant accumulating on the leaves of the trees. So that means you spend these huge amounts of money to give people clean drinking water, but what about the creatures in the trees who are being exposed, and the birds and the bees and the bats who aren't doing so well, and exposure to PFAS isn't helping. So this is a huge problem, and Slide 21, PFAS are problematic and difficult to clean up, and prevention is preferable. And in case you're getting too depressed hearing all these bad things, I want to tell you that a lot of good things are happening, and I'm going to tell you the good things now. So we recommend only use PFAS in products where it's essential. There are some essential uses, but, oh goodness, my slide just switched. Sorry, okay. There are essential uses, but we think if PFAS use was limited to essentials, we could reduce the use by 80 or 90%, even more, which would lead to a much healthier world. So there's a paper on the concept of essential use, and you can find this reference. Just put it in Google and learn a lot more. But uses that are not essential are things like dental floss, water repellent surfer shorts, ski waxes, and there are other uses that are regarded as essential, but alternatives have been developed, and then there are other uses where we need alternatives. So slide 24, to say that our institute, along with ACAT and 4 other communities with contaminated drinking water, has worked with UC Berkeley Law to petition for regulation of PFAS. It's a petition to the EPA to ensure safe management of PFAS waste, and this would also result in an automatic CERCLA listing, which would speed site cleanups and help transfer the liability from communities to those responsible for the contamination. Thank you, ACAT, for being part of our petition. Some really great news. This year, the military budget, which was signed in December, and the military budget always gets signed, so it's a lot of things get put in there that are really important. And to do that, there has to be cooperation from both sides of the aisle. And there has been great cooperation from both sides of the aisle on PFAS, because legislators with contaminated communities, whatever their political affiliations, support solving the problem. So Tom Bruton and I, who've been working on this for a long time, are just amazed at some of these provisions. We've for years been talking about that the military is required to use PFAS for firefighting foam, while other countries don't use it. They use safer alternatives that put out the fires. And our military regulations specify it has to be PFAS, but no more. The military is required to phase PFAS out of firefighting foams in the next couple of years. The U.S. Geological Survey is going to do nationwide water sampling, and when you sample, you tend to find PFAS. For example, the state of Michigan only had 2 sites during the previous EPA sampling, which was only large water systems. But when Michigan looked all over, I think they're up to 60 or 70 sites. So people will learn they have PFAS in their drinking water. They can get safer drinking water, and the political will, I think, will increase to solve the problem. Another great one, we think, is they've prohibited fluorinated packaging in meals ready to eat. The military has, and it's a beginning, I think, of selecting and purchasing against products containing PFAS. Slide 26, Europe is adopting total PFAS drinking water standards. So just instead of just looking for PFOA or PFAS, OS, or the sum, they're looking right now for 20 PFAS, but they want to develop a method for looking at all total fluorine. And that is how to really figure out what's in water and to start solving the problem. The idea of a total phase out of PFAS except for essential uses is gaining traction in Europe. There have been proposals from Scandinavia and Germany to take action to phase out unessential uses of PFAS in the next few years. So this is amazing. There's a movement away from PFAS in food packaging. Taco Bell just announced they are phasing out PFAS, and we've heard most of the other major fast food manufacturers are following the same track. We'll see, but that's what we've heard. Slide 29, Denmark has led the way for countries in banning all PFAS in paper and paperboard food packaging, which is really a good thing, and hopefully other countries will follow. The largest source of exposure to PFAS for children was PFAS-treated carpets, and there were studies showing that. And we actually started meeting with the carpet industry a couple of years ago, sharing the science, explaining them that C6 really was not a great substitute for C8, and they understood the science, and based on the science, the major manufacturers committed to phasing out PFAS, and they've been doing it, such that Home Depot can now say they can phase out selling rugs and carpets containing PFAS because the manufacturers are pretty much all out of it. And this is our model, the Green Science Policy Institute, that when you share science with manufacturers, with purchasers, they can move to healthier alternatives as a way of reducing harm. All these brands in slide 32 have phased out PFAS. IKEA is one we worked with back in 2015. They learned about the harm and within a year phased it out of all their products worldwide. And there were not good solutions for tablecloths, so IKEA stopped selling tablecloths. There aren't such great solutions for oil and water repellency, though there are for there aren't good solutions for grease repellency, though there are for oil and water repellency. So all these brands in slide 32 are out of PFAS. So looking at slide 33, you can see carpeting, food, furniture, outdoor gear, clothing, and firefighting foam are all moving away from PFAS. North Face recently sent me a new jacket with no PFAS, their first one, which I've been wearing skiing this winter, and it's really great to have a PFAS-free jacket. I guess one thing I should just take a minute to say, I'll go back to slide 33, is the problem with Gore-Tex and Teflon is not so much the exposure you get, because PFAS is a polymer, a big molecule in Gore-Tex and Teflon, so you shouldn't get too much exposure if it's all big molecules. The problem is the manufacturer. So in the movie Dark Waters, it's the manufacturer of Teflon that has contaminated the drinking water and the communities in West Virginia and Ohio. If your Teflon pan is scratched or you heat it too high, it is a problem. Similarly, your Gore-Tex jacket, it's the manufacturer. So when people say, should I throw away my Teflon pan or my Gore-Tex jacket, I always say, don't buy another one. It's the manufacturer that's the problem. On the other hand, places like carpeting, firefighting foam, protective coatings that spray on shoes, that is a monomer, a single molecule, and that can be directly harmful. So I just want to end by saying that we have a website on slide 34 called PFAS Central, where we change regularly with the latest news, science that's curated, and we find the most important papers and write one sentence about them. Policy, we also have PFAS meetings, jobs. This came about because 100+ scientists on our monthly calls were always sending us all this information that we shared with them, and we decided to share it more widely. So go to PFAS Central if you want the updates on PFAS. And last, we send out monthly newsletters, and you can sign up when you go to PFAS Central, or if you go to our website, greensciencepolicy.org, you can learn more about the other classes, also sixclasses.org. We have lots of websites, but each one leads to the others. So we hope you'll stay in touch and sign up for our monthly newsletters online. So I just want to end by saying, by limiting the use of PFAS, we can have a healthier world. And we're the Green Science Policy Institute. Thank you.
Thank you, Dr. Blum. I really appreciate you taking the time to share that with us. That was really informative, and I think a great lead-in to our second speaker, the acclaimed attorney and author Robert Bilott, whose recent book, Exposure, became the basis for the film Dark Waters. And he's here today to share some of his story. Mr. Bilott, the floor is yours.
Thank you, and I appreciate having the opportunity to talk to everybody today. And thank you, Arlene. That was a terrific overview. What I'm going to try to do today is just provide a little history of how we got to where we're at today, and how how we came to know what we know about PFAS and where we're likely headed. First, as a lawyer, I just have to make a couple quick disclaimers. I'm not here today speaking on behalf of any client. I'm just going to be giving you my own personal views, my personal opinions of the history here. I first got involved in PFAS issues back in 1998. I was working at my law firm where I'm still working, actually going to be there 30 years this year. Got a call from a gentleman out in West Virginia who was complaining about cows that were getting sick and dying on his property outside of Parkersburg. Could we help him figure out what was going on? And it was in the context of helping that gentleman, Mr. Wilbur Tennant, and his family, that we came to discover that there was a chemical in the materials disposed of in that landfill that, frankly, I had never heard of at the time, and there was very little information available publicly or to the regulated community about what this was back then, chemical called PFOA. And as we all know, PFOA is one of the PFAS chemicals, one of the ones, as you heard Arlene mention, has this carbon-fluorine bond of 8 carbons attached to fluorine. In the context of that case, when we were trying to figure out what is this PFOA, and what does it matter if you've got 7,000 tons of PFOA-soaked sludges in this landfill? Should that be an issue? That we started digging into internal files from DuPont that were able to shed light on what was known about this chemical, and frankly what had been known for quite some time about the toxicity of the chemical, its unique chemical structure, and the potential risks. And so as we started digging through the internal documents about the chemical, we came to understand that there were toxicity tests going back into the 1960s. This was a chemical that had been invented by 3M right after World War II, and the DuPont company had been purchasing it beginning around 1951 to use in the manufacture of Teflon at its plant in Parkersburg, which happened to be the world's largest Teflon manufacturing facility. This chemical was used as a surfactant, not an ingredient in the products, but something that was used to help make the Teflon materials. And that DuPont had started purchasing that and actually purchasing very large quantities of it beginning in the 50s. And this is decades before the US EPA even came into existence in 1970, decades before the first federal laws regulating chemicals coming out into the market came into existence, the Toxic Substances Control Act, which didn't come out until 1976. So this material is being sent down to DuPont in large quantities, and because of its unique chemical structure, the DuPont scientists began studying and looking into its potential impact into the environment, into people, and those who are being exposed early on. And by the 1960s, their own laboratories were revealing all kinds of toxic effects in multiple animal species. And by the 1980s, there had actually been one of the first cancer studies done with PFOA, in which DuPont's own scientists actually characterized PFOA by 1988 as a confirmed animal carcinogen, possible human carcinogen. And the company began monitoring its workers as well, because what was also known, and 3M and DuPont became aware of this in the late 1970s, is this chemical, not only does it get out into the environment, as you heard from Arlene, and once it's out there, because of this chemical bond, will stay there virtually forever. It doesn't break down in the natural environment. The chemical also has this uncanny ability to get into living things and get into blood and circulate and build up to higher and higher levels over time. So the DuPont and 3M had started monitoring the workers and had seen that the level of PFOA was in fact getting into the blood of the workers and was in fact building up. So they started tracking the workers. And what we saw in the documents were concerns about liver effects, concerns about birth defects, concerns about cancer, rates at the company. And as I'm going through all these documents, this is the summer of 2000, early 2001. What I'm seeing is not only do we have all this information suggesting that this chemical is toxic, persistent, bioaccumulative, carcinogenic in animals, that humans are being exposed, but that DuPont's also aware it's being emitted out into the environment from this plant, into the air, where it's traveling directly into Ohio, where it settles on public water supply well fields, but also into the Ohio River in very large quantities, and into the groundwater around the plant. That it had gone out and actually sampled the drinking water and found this chemical in drinking water in Ohio and West Virginia as early as 1984. And even though this chemical had predated the Federal Toxic Substances Control Act and was an existing chemical that really had not been subject to much regulation, DuPont scientists had actually looked at all of this information and said that they established a community exposure guideline, really the world's first drinking water guideline for PFOA back in 1988 after the cancer data came out. No more than 0.6 parts per billion, which they rounded up to 1 part per billion. And the reason that's significant, we're all talking parts per trillion now, but the reason that number is significant is because that was essentially about the same level as the detection level back then. So, if you look at one of the, here you've got the first drinking water guideline being set, and it was essentially being set at the level it could be detected because of the toxicity, the persistence, the bioaccumulation potential, and the potential for cancer that was seen in the rat studies. Well, unfortunately, the drinking water sampling had shown levels in the drinking water above that level. And as we're reading this, I'm realizing, unfortunately, that the public had not been alerted to any of this, nor had the government regulators. So we likely had tens of thousands of people who had been drinking this for quite some time at levels above the levels that the company itself had set, and that, frankly, nobody really knew about it. So at this point, when we found out that there was this massive quantity of PFOA in the landfill that the cows were being exposed to, we were able to settle the case for Mr. Tennant and his family. That was in 2001. Yet we now knew we had massive exposure to this entire community. So at that point, I sent a letter to the US EPA, March 6, 2001, 19 years ago, suggesting that a drinking water guideline should be set by the EPA and that steps should be taken to come in and immediately address potential risks from PFOA exposure. Unfortunately, that didn't happen very quickly. So the community at that point was looking for a way to get this out of their water and to get medical testing. So we agreed to bring what became the nation's first class action lawsuit on PFAS chemicals. That was back in 2001. We brought it on behalf of the entire community around that plant that was drinking this chemical in their water. And soon thereafter, I began sending as many documents as I could to the US EPA and to government regulators from the internal DuPont files that were revealing the extent of this public health risk. Non-confidential information, but that was suggesting this presented a risk of harm and asking the agencies to act. And by September of 2002, US EPA did announce a priority review of PFOA. And by spring of 2003, came out with their first risk assessment and suggested they may even take steps to begin banning the chemical under the Toxic Substances Control Act. In 2004, the agency actually sued DuPont, alleging that it had improperly withheld information about the toxicity of PFOA, in particular the fact that it could cross the human placenta, and that it was in public drinking water supplies above levels that the company had set. And shortly thereafter, DuPont ended up settling. The litigation by the EPA ended up paying what at the time was the largest civil administrative penalty in the history of the agency, $16 million. And it also settled the lawsuit in West Virginia, where community there was finally provided water filtration systems, granular activated carbon systems were installed for the public water supplies. People with private wells that were impacted got in-home systems, all paid for by DuPont. But most importantly, the community wanted to know what this chemical would do to them in the long term. So we set up an independent panel of scientists jointly selected by the community and by DuPont. Independent panel, though, had to be epidemiologists that had never worked for either side, were independent. And believe it or not, we actually were able to pick 3 scientists that both sides agreed to. And they are what you've probably heard to as referred to as the C8 Science Panel. And then they were given a rather extensive task. They were told they were going to look at all of the existing data, not just what was out there published and peer reviewed, but also all of the internal data. And they were going to study the community that was impacted in drinking this. And their task was to determine whether or not drinking that chemical in the water at the levels in that community were linked with serious disease. And nobody had really ever done this before, and we weren't quite sure how long it would take or how complicated it would be. But we're actually fortunate enough to have 69,000 people in that community who participated, gave blood, provided medical records, and all of that data was turned over to this independent panel, who was then able to develop some of the most comprehensive, massive, expansive human health studies ever done on any chemical. Took them 7 years. They did 12 different epidemiological studies, a massive retrospective exposure model, some of the most impressive human health studies ever done. And they completed their work in 2012. And when they were finished, they ended up announcing that they had linked exposure to PFOA to 6 different diseases: kidney cancer, testicular cancer, ulcerative colitis, thyroid disease, preeclampsia, and high cholesterol. And at that point, once those links came out and were confirmed, we reiterated our request to EPA, that we now have some of the most extensive human health data ever done by independent scientists confirming these links with human disease. What more do we need to set drinking water guidelines? At that point, the EPA included PFOA and the related chemical PFOS that have been used in Scotchgard and firefighting foams in the unregulated contaminant monitoring rule, where drinking water supplies went out for the first time. These were typically the larger drinking water supplies, those serving over 10,000 or more. But we had sampling occurring, finally, for the first time nationwide for PFOA and PFOS. And that data started trickling into EPA 2013, 2014. And what also happened is once those links had been established by the independent panel, all of the people in that community along the Ohio River in West Virginia, Ohio, that had been exposed were entitled to medical monitoring to be paid for by DuPont. But also anybody that had one of those diseases had the right to go forward and seek damages from DuPont for their disease. And under our agreement with DuPont in the settlement, DuPont had agreed it would not dispute that once those links had been found, that it would not dispute that PFOA was capable of causing those diseases at those levels. And so those lawsuits started to get filed in 2013, 2014, about 3,500 eventually were filed. And the first one started going to trial in 2015. And so you had the first trial ever against a PFAS manufacturer based on the allegation that the exposure had actually caused physical injury. And that verdict came back in 2015, holding DuPont responsible for having caused a woman's kidney cancer. There were 2 more trials, both also verdicts against DuPont, including punitive damages, saying that the company had acted with conscious disregard of the risks. And significantly, a New York Times article came out, New York Times Magazine, in early 2016, that summarized all of this history and really kind of put it together for the first time. And importantly, also identified various places across the country where this chemical was now being found under the UCMR testing. So communities all across the country suddenly started asking, what is this? Why is it in our water? And what's the appropriate safety guideline? And this was 2016. And unfortunately, at that point, we still had no enforceable drinking water guideline from the EPA. So just a couple months later, May of 2016, we get the very first long-term drinking water exposure guideline coming out from US EPA. That's the one I think most people are familiar with, the 70 parts per trillion combined for PFOA and PFOS. And that had a significant impact because the Department of Defense realized that these chemicals, PFOA and PFOS, had been used in firefighting foams historically and had been sprayed in training exercises and other uses outside military bases and airports all across the country. So when this guideline came out in 2016, the Department of Defense put together a big list of sites where these foams may have been used and started sampling them, going down that list. And beginning in late 2016, almost every day, a new community somewhere in the United States was learning that these chemicals were in their water and that they were above the level set by the EPA. And so you had even more demands that the EPA set an enforceable standard. In the meantime, states started moving forward and not wanting to wait, for the enforceable standard from EPA, started setting their own guidelines. And as you heard Arlene mention, those numbers have been coming back even lower than the EPA guideline of 70. You have lower guidelines from New Jersey, Vermont, New Hampshire, Michigan, New York, and those numbers are going down lower and lower. And as that information has come out, people are also realizing it's not just PFOA and PFOS. As you heard from Arlene, what has happened is as information finally came out to the public over the last few years about PFOA and the hazards, and that chemical finally has been phased out in the United States, these substitutes and replacements, things with C6 or C4, things like Gen X that DuPont has brought out to replace PFOA, those are now being found in water across the country. Gen X, for example, is being found in drinking water outside the production facility down in North Carolina. State of Kentucky just sampled water supplies along the Ohio River outside of the DuPont plant out in Parkersburg. Sure enough, Gen X is in the water all the way down the river in Kentucky already. So people are, as you heard from Arlene, you have scientists and regulators who are now saying we need to address this entire class of chemicals now. We need to be looking at this comprehensively, because if you step back and look and you say it took us 20 years to finally bring out to the public what was known for decades about the health risks of PFOA. And as we start to learn about these other PFAS chemicals being out there, what we're hearing is a very similar refrain. Well, we just don't know enough yet. There's not enough out there about the health risks from these chemicals. Well, that's exactly what we heard 20 years ago about PFOA, and we now know that was not accurate. So I think folks are concerned that we should not be waiting to take 20 years on each of these additional chemicals. That steps ought to be taken now. And we're seeing that. In the EU, I was in Europe a week or so ago, and there's discussions now in Europe, in the UK, elsewhere, that to try to address these chemicals as a class. And I know I'm running out of time, so I'll try to wrap this up. But one of the things I've been trying to do for the last 20 years is help bring this information out to the public, help bring it out to the scientific community, to regulators, so that everyone can be aware of the extent of this risk and be able to take steps to address it. And I'm very pleased to see the movie Dark Waters come out, my book, Exposure, that summarizes this history, to help make that information available to people, to help spread the word about what these chemicals are, and most importantly, what we already know about them, so that other communities don't have to repeat this 20-year saga that was experienced by the community out in West Virginia. We can take what we already know, learn from that, move on, and hopefully spread awareness of this. So thank you so much for giving me the time to talk to you. I'm hoping And I'm encouraged, as Arlene is, that we are now seeing these conversations and discussions occurring at the federal level here in the U.S., at states all across the country, all across the world, that we now need to, I think there's recognition that we now need to be taking steps to address these comprehensively and to do it now. Thank you.
Thank you, Rob, both for your work over the preceding decades and for joining us today to share that. And the book, the movie, I could go on. But by no means least, we're joined by Pam Miller, the Executive Director at Alaska Community Action on Toxics and co-author of a 2019 report here in Alaska, Threats to Drinking Water and Public Health in Alaska, the Scope of the PFAS Problem. Take it away, Pam.
Thanks, Nick. And I just want to also echo Nick's thanks to Arlene and Rob for your just excellent presentations. We're so grateful that the two of you are speaking on our CHE call today and sharing your extensive knowledge and experience. And we're also very excited to welcome you, Rob, to Alaska in a couple of weeks. I'm going to give just a very brief overview of some of the PFAS concerns in Alaska, and then some public policy efforts here in the state to address these public health concerns. And as Nick mentioned, we did publish an investigative report last fall. For this report, we reviewed hundreds of pages of documents that we obtained through public records request, and also did a thorough review of the peer-reviewed scientific literature, and that is available on our website. The purpose of this report is to inform the public about the issues and necessary actions to address this public health crisis. And we note that instead of acting responsibly to protect the health of Alaskans, the Governor Dunleavy administration rolled back protections this last year that were in process under the Walker administration. And in Alaska, as everyone knows, we're a very aviation dependent and also have many military bases here in Alaska. And the dispersive use of aqueous film forming foams, or AFFF, on military bases and airports has contaminated the drinking water of communities from the North Slope of Alaska to Southeast Alaska. We have no enforceable drinking water standards, as our previous speakers have noted, either at the state level or at the federal level. And I just want to note also that health effects are found at up to 700 times the guidance level that has been established by EPA, that's 70 parts per trillion. So health effects are found in the peer-reviewed literature at the 0.1 to 1 part per trillion level. So we have a ways to go in regulating these dangerous substances. Some of the key findings of the report: Alaska is still in the very early stages of investigating known and suspected sources of PFAS contamination. And to date, PFAS have been discovered at over 100 individual sites. These are mostly AFFF source areas in nearly 30 locations. And at least 10 Alaska communities have PFAS in their drinking water at levels deemed unsafe, even by the guidance levels established by EPA, which we think are not protective of human health. And it is also likely that the number of communities with contaminated water will grow as more sampling is conducted throughout the state. To date, we have no investigation of wastewater or biosolids derived from sewage in Alaska to determine the extent to which these sources may be spreading PFAS in the environment, despite the fact that PFAS are found in wastewaters discharged into Alaska's rivers and Cook Inlet. Leaching of PFAS from materials deposited to landfills may also be a source of surface and or groundwater contamination, and this has not been investigated. We've had only very limited testing of fish tissue, and that has confirmed that some fish in Alaska have levels of PFAS that exceed consumption advisory levels established by other states. And as we know, many Alaskans rely on both anadromous and resident fish species for subsistence. We know that lakes and rivers and coastal areas on or near several military installations where PFAS have been detected, and this suggests that as a precautionary measure, the state should prioritize the testing of fish for PFAS. And I just want to note that the true cost of PFAS contamination is not simply represented in the hundreds of millions of dollars already spent on site characterization and sampling, the direct financial liability, and the likely billions that will be spent on remediation, but in the immeasurable harm to public health and the environment. And I won't go into them, but we have a series of recommendations in the report that really do follow, I think, Robin and Arlene's recommendations of taking a class approach to these harmful chemicals. And we're very pleased that Senator Jesse Keel, who represents districts in Juneau, Haines, Skagway, Gustavus, and Klukwan, introduced Senate Bill 176. This is a bill to establish limits on certain PFAS substances in drinking water, provide for more comprehensive testing of water sources, allows voluntary testing of the blood of affected community members and first responders, and also leads us toward phasing out the use of PFAS in firefighting foam. The bill is co-sponsored by Senators Elvie Gray Jackson, Bill Wielechowski, and Tom Begich, and we have a companion bill, HB 240, which was introduced by sponsors Representatives Sarah Hannon and Garen Tarr. So we're very grateful for that and look forward to working with our legislators and the public to get these bills passed. The bills are referred to the Senate and House Resources Committees. Thus far, we do not yet have hearings scheduled for these bills, but we hope to get PFAS legislation passed this session. So please do let your legislators hear of your support and call for hearings. There are ways that we hope the legislation can be strengthened, and we will be working to ensure that this is as strong and health protective as possible. And ACAT continues its work at the state, national, and international levels to eliminate the harmful uses of PFAS with our partners throughout the world and to prevent further harm. Thank you so much.
Thanks, Pam. And thanks to all our speakers. With our remaining time, we'd like to invite questions and comments from our participants. If you'd like to ask a question, you can press *2 to unmute your line, state your name and affiliation. And if you can, remember to remute your line when you're finished just to keep external noise down. And yeah, maybe let's give preference to local calls to begin with. So any Alaskans out there with any questions or comments, go ahead.
Hello?
Hi there.
This is David Dow from Cape Cod. I had a question about waste site cleanup. The Joint Base Cape Cod, Shumat Valley plume lies underneath the development where I live, and it's caused problems with private and public drinking water wells. It turns out the source areas are the former fire training area, the former wastewater treatment plant, and the water and sediments in John and the Shumat Pond. I was wondering what kind of techniques are available to remove PFAS from the source areas.
This is Arlene, and I'll just say that that is a really hard question. I don't think either Rob and I are experts. Maybe Pam knows more about that, but basically, clean drinking water can be given to residents, but particularly large water sources, once they're contaminated, it's incredibly expensive and difficult, which is why we think prevention, stopping the use, is the most cost-effective thing to do. I don't have real expertise in this. What about you, Pam? Do you know the answer at all, or Rob?
Yeah, it's Rob. I would defer to others on this issue, and I think it's an area where we've got a real emerging area of research. I mean, people are really looking into it right now.
Yeah, this is Pam. I would just agree and say that we probably need a Che Alaska call just on that topic, or a Che call in general about treatment technologies.
Thanks very much for that question. Does anyone else have a question or comment to share?
This is Karen from San Francisco. Can you hear me?
Yeah, you're on.
Okay. I just wanted to ask a question about the EU policy. Since they have adopted the precautionary policy there, I was wondering if either of the speakers could answer the question of where they are with their elimination of PFAS, either in their supplies or in their, in their contaminants environmentally.
I don't know if you heard my talk, it's Arlene. I put in a few examples that they are ahead of us, but it's still a slow process. The Scandinavian countries and Germany are calling for PFAS only to be used for essential uses starting in 2025, but it's a process, you know. So they are moving ahead. Just a couple days ago, they set quite a low level for food, though the new food level has just come out, and there's a call for public comments. So a lot of different European agencies are working on the PFAS problem ahead of our EPA, but it's still a slow process.
Thanks for that question, Karen. Oh, go ahead, Kathy.
Hi. No, it's Patty from Alaska. I loved hearing about all the things that are happening with the policy changes and the purchasing changes. But we all know, and the litigation, but we all know those are all long-term things, and they're aimed at prevention, which I think is stunning. It obviously is where we start, but my heart goes out to the people whose water supplies are currently contaminated or who fear that their water supplies are contaminated based on proximity to known sources of contamination, like, you know, old military bases and what have you. So my question is, if you know or suspect that your drinking water is contaminated, as a person maybe on a private well or a person in a community using public water, what can people do in the short term? I mean, I get that we need to fight for policy change, but, you know, if your water is contaminated right now, you're sitting there looking at that glass of water and going, can I actually swallow this crap? I know it's a hard question.
Arlene, do you want to take that one?
Well, people can put in reverse osmosis systems in their homes. I know Heather Stapleton, who's a leading scientist who lives in North Carolina, has done that, and that's expensive. It's really problematic, and as what's considered the health advisory level goes down, more and more people's drinking water is going to be above that level. There's an estimate right now, as we said, the health advisory level is 70, and the company Eurofins that did a lot of those measurements for the EPA also measured lower levels, and they calculated if the level went down to 5, it would be 20% of the drinking water in the country. So the cost of clean water is huge, and everyone deserves clean water. And then the cost of remediation is even huger. So it's really a, Rob wants to add to that.
No, nothing to add. That was good.
Hello, I would just say in addition, this is Pam, I would just say in addition that we work with communities just to ensure that for those who can't afford reverse osmosis systems because they are so expensive, that it's important collectively as communities, people that have private wells that are contaminated, to fight for a water source that is clean, that is upstream from the PFAS contamination. And for example, in Fairbanks, people that are on private wells are now getting water sources from the public water source in Fairbanks, Golden Heart Utilities, that is contaminated. So that's just not acceptable. We have to fight for communities to get clean water sources that are also not found to be contaminated with PFAS.
Could I ask a question?
Yeah, I think we have time for one more question, so dive in there.
Yes, this is Nancy Price in California. I wanted to ask about drinking water, bottled water. Is there any way that is being regulated or tested for PFAS? I know that there are many brands that are not spring water, they're municipal water being used for bottled water. So I'd like to know about that, please.
That's a really good question, and I don't know the answer. I'm afraid. I don't know if anyone else on the call does, perhaps, or if Pam or Rob know it.
This is Rob. I know it's a question that has come up quite often. There's historically been circumstances where, you need to be concerned about where the bottling is happening, and to make sure that the bottling is not happening from one of these aquifers that we already know has a problem. But I'm not aware of there being any sort of comprehensive approach to that at this point, unfortunately.
Might I add too? Is this talk and the slides going to be available to the public, or at least to us who are on this call? Will the slides be posted somewhere?
You've provided me the perfect transition. Yes, indeed.
Oh, good.
Yeah, so I want to thank everyone for participating today. And yeah, I'll be sending out an email within the next day or two with the recording of this call. And there's already a link to the slides, but with that again. And so our next call will be March 25th to discuss mushroom-based bioremediation with the owners of Far North Fungi here in Anchorage and Dr. Birgit Hagedorn of Sustainable Earth Research, talking about their pilot studies taking place in Alaska, and a discussion of how their methodologies have strengths or limitations here at higher latitudes and colder climates. And finally, I hope you'll consider making a donation to Alaska Community Action on Toxics to help support our monthly CHE calls. Your contributions help provide the support we need to continue bringing you these calls each and every month, and you can give them online at our website here at www.akaction.org. If you have any additional questions or comments, please feel free to contact us by calling us here at our office number 907-222-7714. And yeah, thanks again to everyone, our speakers, our participants, and I hope you have a wonderful rest of your